going on, YouTube? Episode 5 of this cross kart build. So in the first 4 episodes, you saw making the front hubs, not the front hubs, the rear hubs with the CVs and the big bearings, my cool billet hubs. So now we are moving on to the center diff, the center spool. Also going to be running some big bearings, not big CVs, but 930 CVs inside of those big bearings. And so I'm getting things modeled up in Fusion 360, which I've pretty well got them modeled up, basically ready to start making a few parts on the mill. So this next video is going to be, focusing on making some of those parts in the mill. Probably do a lot of time lapse on that. Maybe I have had a few comments of guys wanting to have me get a little more in depth on what it takes to kind of bring a part from Fusion, from the computer world, and kind of bring it into reality and kind of the steps it takes to get from A to B on that. So anyway, that's what we're gonna do. Episode 5 is gonna be starting to make some of those parts for the rear diff, maybe a little bit of technical information on how I actually program the machine. And yeah, so sit back, make sure to hit that subscribe button, and maybe leave me a comment. Let me know what you think about these videos, how I'm doing. That's it. All right, guys, sit back. All right, let's get things fired up here. Not sure if you guys have heard of this. This is a phase converter. Built this thing a couple years back. Basically it takes single phase, 220 single phase power. So like the same power that you would use to run your dryer, your oven in your house. So it takes that 220 and then it converts it into 3-phase. So like in a commercial setting, normally a lot of equipment would be run off a 3-phase. So it's 3 legs of like 120-ish. So anyway, so this box and this motor convert single phase 220 into 3-phase. So the Fadal, the Fadal mill, the old Monarch lathe, the press brake, pretty much all this commercial machinery, for the most part, they're all run on 3-phase. So it's not hard to make a phase converter. You can also buy them. Obviously, if you got the money, you can just go buy one. But there is quite a bit of information on YouTube about phase converters. So it's definitely something that can be done. I've made a few. This is a 40 horse converter. So you need to have a converter big enough. Needs to be like double the size horsepower wise than the biggest horse-powered motor, on one of your pieces of equipment. So anyway, this is 40 horse. The Fadal has a 20 horsepower spindle. So I needed to have like a 40 horsepower phase converter. So anyway, thought I would mention that. There we go. So the big motor is basically like a generator. You fire it up on single phase. There's some capacitors in that box. It jolts the engine or the motor started, and then once it's running, idling, that third leg is actually generating power, making 3 phases of power. It's pretty cool. And then in that box as well, there's capacitors in there that balance out the legs. So you put capacitors between the legs, and that balances out, so you get equal voltage between all 3 legs. Anyway, thought I'd mention that. Throw the switch. Come on, baby. Yeah. I don't know what it is. I really like that old school look. I think it's sweet. Start. So right now it's basically it's homing itself out. It's finding its zero. So what we're doing here is earlier today I did the first op on this first part of this hub assembly, and you can see it here. You can see this side's done. I've got it upside down in my super spacer, it's called, in the chuck here. So I got it flipped upside down. I have indicated off this hole to find center on this side. So this is op 2 of this part. So now I need to load op 2 off Fusion and load it in the machine and go ahead and cut the second op. So if you guys are interested in CNC machining at all and you don't have the money to drop, you know, 100 grand on a new machine, an older Fadal like this is a good option. So this is like a 1998 Fadal. This is my third Fadal that I've owned. The first one I had, if you look back in some of my other videos, you'll see my older Fadal that I had. But anyway, Fadal was a brand that came out around the same time that Haas came out, from what I understand. They're both from California. I think they were both started in the same industrial park, so they were like neighbors. So they were competitors from early on. Fadal didn't do, I don't think, as well as Haas did, but Fadal was still a really good brand, made in America. And what's cool about an old Fadal is there's still a ton of aftermarket support for them. There's a company called cncpros.com, a website, and you can get every part and piece for this machine. Also, they have all the technical information, user manuals, just little procedures for doing certain things on these machines, for like setting them up and changing parameters and all the little quirks and all the little things you need to know to run a Fadal. So plus there's quite a few YouTube videos online, guys that have these that are using them, especially guys that are using Fusion 360 and using Fadal. So they communicate pretty well together. One thing you need to have, though, in order to run one of these reliably with Fusion, is you need to buy CalMotion. There's a company called CalMotion sells this little USB drive. And so what that little box does is you can plug your thumb drive into it and it'll drip feed all the information to the machine. So, you know, these older machines don't have the memory that, you know, your smartphone has quadruple, I don't even know, has way more memory than this old Fadal does. So you can't, on some of these more complex parts with like a lot of surfacing, there's not enough memory in this machine to load all of that G-code and save it on the memory of the machine. And so what this little thumb drive, this little CalMotion box, you're basically loading the information onto that box, and then that box is drip feeding that information to the machine. So as it's cutting, it only digests what it can handle. So it'll just drip feed a little bit of information and it'll process it. And then as it's working its way through the program, it'll just continue to load that information. And then eventually you got a part. So this machine, this particular Fadal, I found two of these machines that were super nice. And the guy that bought these originally got every option. So this one has the expanded memory. It has the extended Z height. So it has 28 inches of Z height, which is pretty cool and very handy to have. My other Fadal had like 20 inches of Z height. So this has 8 more inches of Z up and down, which is very handy for like stuff like this where you have a lot of stack up there. I got super spacer and my part, and then if you're running, you know, long tools, you know, you don't have enough Z to do some of that. So this machine also has rigid tapping, it has high-speed spindle. So this was kind of like had all the options. It also has a 5/5 axis attachment. Never used it, but it has one, so I am excited to try it out. But anyway, so just a little rundown of the machine, kind of what it is, and it's super nice. I was super happy to buy this machine. You guys might have seen the other one. I bought 2 of these at one time. I had another one sitting in here for a while. I didn't really have room for it, or I didn't have the work to keep it, to use it. So I ended up selling it. But anyway, that's the rundown on the old Fadal. Second off of this part, you may have seen me in the time lapse sitting here kind of fiddling at the control. I got a little chatter going on, and I'm trying to adjust my feeds and speeds, trying to get rid of that chatter sound. I don't think it's a big deal. I can just tell on when it's machining on certain sides of the part, it's got a little chatter. So sometimes you can sit here and adjust your feeds and speeds manually to try to dial it in just right, so it's, you know, kind of get rid of chatter or vibrations that you don't like. So I think part of the reason it's chattering is because I'm using a pretty long tool, and I think it's just the harmonics of that long tool causing a little chatter sound. But that does it. Yeah, still doing it a little bit, just adjusting the feed rate a little bit. So I'm probably doing like a 2-inch step down and probably a 30,000th step over, running at about 100 inches a minute, and I am at 8,000 RPM. So I'm using a 1-inch 5 flute core 5 Cannon metal core 5 flute end mill. So yeah, so right now it's roughing it out. It's kind of hard to see. There we go. But right now it is going through like a roughing process, taking out all the excessive material. Doing what you call an adaptive tool path. So fusion knows that you never want to bury an end mill into the material, into the aluminum or the steel. You never want to surround the end mill. You want to keep a certain percentage, or you only want to cover up a certain percentage of the actual end mill. You don't want to like cover like 3/4 of it. You don't want to wrap the material all the way around the end mill. You want to cover maybe 10%, 15% of the end mill at one time. So fusion does an adaptive clearing where it kind of will peck away at the material and keep the end mill in a good position throughout the procedure. Anyway, pretty cool. Yeah, I don't know, without having like Fusion 360 or something like that, I don't know how the old timers made parts. They would have had to have done this all right here at the machine, punching in G code. This is all G code. This is all lines of code. So to write a program on this machine, you'd have to sit here and type in each line of G code. So it's pretty amazing. They definitely probably weren't making the complex parts that we can make today. There we have it, guys. Ooh, it looks nice. All right, let's get this thing blown off here. So what I want to do here before I take this part out of the vise, I need to get one of the bearings and get one of the CVs and see how they fit. So it's a little snug still. I want this thing to be just like a nice slip fit. And here's one of the CVs here. Let's see how it fits here. So sometimes when you're trying to get within like a couple thousandths, you know, you have to go back and basically rerun the program. You know, a tool, like especially like a longer tool, you do get a little deflection. The tool actually bends a little bit, and so you have to go back and do what you would call a spring pass. Take out, try to get, you know, within a couple, like a 1 thou, 1.5 thou slip fit. So I'm still a little bit oversized. So I need to go back, load those 2 contours and rerun those, and then check and see how it fits. So let's do that. All right, let's get this thing punched back in here. All right, it's all loaded up here. Shut the doors, or maybe I'll see if I can clean off the glass there so you guys can see a little bit. All right, start. Oh, let's turn the coolant back on. There we go. All right, here we go. Yeah, so I might taken off a little bit, but based on how it sounds, I don't think it's taken off much. So I might have to go in. Oh, there it goes. Might have to go in, fuse in, and just offset it like a thou. But we'll see here. It is taking off a little bit. Might be all we need. Here. So close. Ooh. Okay. Double lubrication. Right. Exactly. Perfect. Check that out. Nice. That's exactly what we want. Just a nice slip fit. Perfect. Now let's see if the CD fits in there. Still be so close. It's a good little tap, a little. I don't want to, you know. Yeah, I really don't want to. Yeah, might be. One thing I don't want to do. That CD would go in there. The bearing is perfect. There we go. I think I'm going to go back. The bearing surface is perfect. I might just hit this CV opening one more time. I definitely don't want to be fighting that. So I've had to go back to Fusion twice now and take 2 different times. I've taken 1,000ths at a time off to get this CV to fit perfect. So we'll see this time how we're looking here. It's really close. If I hit it with a dead blow, it probably would slide in there, but I want it to be like a slip fit. Like, yeah, there you go, perfect. That's exactly what I want right there. Nice slip fit. No play in it, slides right in. So perfect. So there we go. So we'll call that part done. So I'll get it out of the super spacer, if you want to call it. I get it out on the table, kind of show you what this part does. There we go. Sweet. Alright, so this is the beginning part, kind of the first part of this rear hub assembly. So there you go. Kind of like a hub, you want to call it. So what this does is holds the CVs in place. So there's one CV. Another CV. So there you go, you got your CVs in there. Okay. We got enough room inside for the axle plunge. And we got 2 more big bearings here. Nice flush. On it. Go this way. Other bearing. Like that. Perfect. Nice slip fit. And there you go. The first part for the rear hub. So next thing we gotta do is, this is the rear spool, so the rear drive. So you're gonna have a sprocket on this side, and you're gonna have a brake rotor on this side. And so the next parts that we'll be making will be basically adapter flanges. One flange for the sprocket, one flange for the brake rotor, and those flanges will also keep the bearing on. So they'll bolt through. There's a 125 thousandths step here. So the flange will have a step, or have a boss that'll go in here and index itself inside of this hub, and it'll also hold the bearing and put a little preload on this inner race. So they'll bolt through there, kind of hold everything together. It'll run off these 6 bolts. They'll run all the way through both sides, hold everything together. Here's a brake rotor that I'll be using, 14 inch. It's pretty big, but the reason for that is that'll be on there like so. I have to have room to mount this Willwood caliper. How can I trying to figure out a way that I can mock this up so you guys can see what I'm talking about. But basically, got to have enough room to mount this caliper. The caliper wants to bottom out. If I ran a 12-inch rotor, the caliper would want to bottom out on this bearing. So there's still got to be a bearing, a retainer, a couple flanges that go on here that'll hold the outer race of the bearing to actually mount this in the chassis. So anyway, so I had to run a 14-inch rotor in order to get this caliper out away from the bearing in order to mount it. So anyway, I've got those pieces all designed in Fusion, and so go ahead and get some of the stock cut out for those parts. and then we'll get them up in the pedal and get them cut. So you saw in the time lapse a bunch of different parts being made in the old Fadal, and so I just wanted to explain to you kind of what those were. Sorry I didn't take the time to explain more about the cam, programming, that sort of thing. I know I said it earlier in the video that I maybe would do that, but time got away from me, and I just wanted to get some parts done. So there's going to be plenty of opportunity in this project to kind of get in depth on a little more of the cam and the programming and the whatever of the actual CNC mill. So don't worry about that. You're just going to have to subscribe to the channel and stay tuned for that. So anyway, let's go over kind of what was made in those time-lapse clips, and then talk about them and kind of hopefully explain kind of what the whole process is here. All right, so here we go. This is the diff. These are the parts that were made in the time lapse here. Kind of explain to you a little bit what this is. So this is the rear diff. Obviously we got a sprocket, we got a brake rotor, right? This, you can see the overall width of this. Up inside of here, you will see, that's the CV up inside, tucked up in there. And then on this side, we have another CV that is tucked up inside there. So obviously the axle shafts will run up in there. Check that out. There you go. So there's the axle. You can see it. It moves through all its range of motion. So inside, so basically we have an aluminum hub. We've got these two big old bearings down inside here that are on that hub, and then these two flanges here. Kind of like a bearing support, if you want to call it that. They basically are holding the bearing on the outside of the outside race of the bearing. Got a 1-inch spacer to get these spaced out correctly for preload on the bearings. And then off of these bearing supports, we have the brake caliper mount. And then on either side here, we have what I call the rotor adapter flange. And on this side, we have the sprocket adapter flange. You see these 6 holes. I got 2 bolts in there right now, but those 6 bolts will go all the way through this flange, through the CV, through the hub, through the CV, and then through the sprocket adapter flange. And so those 6 bolts basically clamp, you know, everything together. So the whole assembly basically is held together by those 6 bolts. So between the 6 bolts here and the 4 bolts that hold the 2 bearing supports together with these 1-inch spacers, those are what set the preload on the bearings and, you know, keep everything, you know, tight and happy and where they, you know, where it needs to be. So it's super smooth right now. It feels really nice. Super stoked with how this whole part turned out. So it's pretty cool. It's pretty impressive. So so I was looking for sprockets. What I needed, the R1, it's like it's not a 520 chain. I'm learning here, but I don't know if it's a 530 or a 540 chain, if that makes sense, but it's a little bit, it's the same pitch. So it's a 5/8 pitch, but it's just a little wider, say, than like the dirt bike chain. So anyway, or the go-kart chain, you know, over there. Downloaded a file that basically on McMaster-Carr, you can download any part or bolt or nut or anything you can order on McMaster-Carr. They have a 3D model for that part. So you can just go on there, and on Fusion, there's actually in Fusion, there's like a tab that drop down. You can actually upload McMaster-Carr parts right off of Fusion, which is pretty cool. Anyway, so you can download a model of this sprocket directly off Fusion and pull it right into your program. So that's pretty cool. So I downloaded a 50 chain, I guess that's what you'd call it. So it's a 5/8 pitch chain or sprocket, sorry. So downloaded that into the software. The right amount of teeth that I wanted, which is like a 54 tooth, is kind of what I'm starting out with. So I was like, well, what the heck? I got a mill. I might as well just machine a sprocket. So anyway, that's what I did here. So made the sprocket, which uses, you know, which set my bolt pattern and my inner diameter here. So anyway, that turned out awesome. Super happy about that. Cool thing about that is if I decide in the future, like, oh no, I don't want a 54 tooth, I want a 50 tooth, or I want a 60 tooth, or whatever I want, I can just, you know, pull in a new file and cut a new sprocket. So anyway, super stoked. Got that done. That was a little bit of work for sure. So now that we have, you know, now we have that done, we have the 2 rear uprights finished. Now we can start kind of laying things out. I need to get the motor, you know, I need to get the donor motor pulled out, or the engine for the project pulled out of that wrecked motorcycle over there. And then we can kind of get everything set up kind of on the chassis table and lay this out. I've got a seat that I can borrow, get a seat mocked up, get the motor sitting on the table, get this rear diff and these hubs, everything kind of mocked up. And then we can start kind of laying out the chassis, getting the coilovers kind of where we want them, and start to kind of visualize where we're going. So I would like to, you know, in the past, you know, when you're laying out a chassis or something, a lot of times you're just kind of, you know, feeling it out and kind of putting things where you think you want them and where they'll fit. One thing I would like to do this time around, now that I'm kind of getting more familiar with Fusion and CAD, is it would be nice to be able to kind of design and do some of this in the computer. I'll probably do it simultaneously, get the parts laid out where I want them on the table, try to put that in the computer, and kind of go back and forth. It'd be nice to be able to design this in the computer just so I can possibly have repeatable parts that I could do. Who knows, maybe in the future I could sell a chassis or something. I don't know. Maybe if a guy or gal wants one of these things in the future, at least I'll have it in the computer, and I could duplicate it if I needed to. So anyway, so that's kind of where we're at right now in the project. Next parts that need to be made, it would probably be a good idea to start to make the front upright, front hubs. And so I'm going to be using for that just some Volkswagen parts. So never messed with Volkswagens before. So our Volkswagen parts. So it's kind of fun to kind of use some new things, do some new things never done before. So basically what I'm going to use for that, for the front hubs, obviously this is the rear hub. So this is like a rear, this is like a Volkswagen flange, I guess you'd call it. So you basically have this flange here, and then Volkswagen, they run these big bearing, these, you know, these decent sized bearings, like a wheel bearing, I guess you'd call it. And then so that bearing basically slides up on this, it's kind of a press fit here, but it slides up on this flange, and then the outer race of this bearing would be pressed inside of some kind of an upright. That's kind of what the plan will be for that. You know, it's not a four-wheel drive vehicle, and so this will be perfectly fine for what I'm doing for the front. And then to get the bolt pattern that I need, because obviously, you know, that's a little small, I'll just make an adapter ring that'll take it from this smaller 4-bolt pattern to a larger 4-on-137, you know, Can-Am pattern. So that's the plan with the front. It'll be a little bit simpler setup. Got to do brake hats. Got to do some kind of a rotor. Probably do Willwood stuff for that. I have a couple of more of these little Willwood calipers laying around. So I may even just cut a couple solid rotors on the plasma table, you know, and just drill them and slot them. I mean, basically that's what these are. They're a solid steel rotor. You can actually see the laser, where it was laser cut. You can see the kerf here where it's, you know, not a perfect, you know, part. So I've actually done that in the past, and it works pretty good for something that's lightweight, you know. So that's probably what I'll do. Probably plasma cut a couple rotors out, make some brake hats, and then get all that set up on the front hubs. So, and then the next thing I need to do, you may learn about me, is that I like making stuff. Of course, I could buy a lot of parts. I could just go buy hubs and wheels and whatever. You can buy pretty much anything these days. But I've always been of the mindset, like, well, I can make it, you know? And I know sometimes it's more time consuming to make things than to buy things. Time is money, you've heard that, which is true. Time is money. When you're in a business setting, doing customer work, doing stuff like that, time is money. That's very true. But if you have a hobby and you like to make stuff for fun as a hobby, time, it's fun. It's no different than playing golf or riding dirt bikes or whatever. It's just fun. It's fun to make stuff, you know? It's fun. It's fun running this machine in designing something and then making it and then holding it in your hand. It's a lot of fun. It's kind of the same thing. So what I'm getting at is I have these Polaris wheels. Got off a buddy of mine. He put cool wheels on his Polaris RZR or whatever. And so these are like 2021, 2022. Check that out. 2022 Polaris RZR Pro R something or other. But if you notice on these wheels that they are a 5-lug, so that's not gonna work. So, but I think I'm gonna use these anyway. I'm gonna machine the center out of these, machine a plate, basically like an adapter plate, and put inside of here, and then convert it to a 4-bolt, you know, Polaris wheel. So, you know, I got these for basically free. I'm gonna, at least for now, they'll be fine for mock-up, or maybe I'll even run them, you know, it's something a little different. So I'm gonna do that. I gotta machine the centers out of these, or not totally out, but I gotta machine the centers down a little bit, drill that 4-bolt pattern, make a plate to kind of set down in there, and do that. Then we can kind of get some tires mounted up on these, and that'll help us, you know, getting things mocked up and figuring out kind of where we want to put stuff. So I have envisions on this cross cart of I don't want it to look like a Sierra Cars cross cart or a lot of the cross carts you've seen. You know, I don't want it to necessarily look like a go-kart. I want it to have cross cart parts and like UTV cross cart parts, but I might try to design it, the chassis and the overall look of it, to be a little bit more truck-ish, maybe with more of a little bit of overhang, behind the rear axle, possibly put a fuel cell back there. Little class 1 trophy truck-esque look to it, but kind of smaller, you know, obviously on a smaller scale. So that's kind of what the vision is in my head here. So I think I've done plenty of talking here. Hope you enjoyed the time lapse. Just thinking, I think that's pretty much it. So I appreciate that'll wrap it up for episode 5. Episode 6 will probably be a combination of, I don't know, I gotta decide, but probably a combination of possibly working on the front uprights, front hubs, combination of maybe of converting these wheels to a 4-lug pattern, possibly a little bit of just, you know, tearing this bike apart, getting that motor pulled out and ready, cleaned up. So next video might just be a little miscellaneous stuff. So yeah, so I think that's about it. Appreciate it. If you would, you know, it's free. Subscribe to the channel. Give me a thumbs up. Give me a comment. Anyway, that's it. I've talked long enough. Hope you guys are having a good night, and catch you on the next one.